Hi, ladies and gentlemen. In this video, we are going to keep continuing to cover parent functions and transformations. So this one's set up a little bit different. On our last video, we learned about translating our functions. So we're going to continue to do that. In this one, it's going to be a little different. In the last video, we were given the translations and we were given the translations all in one single sentence, and we wrote our function. This time it's set up in a chart so we can figure out what our translations should be. So we are going to use all of these to write our equation, and then we're going to graph them. So number one, it says my parent function is a quadratic. We know that that is y equals x squared. Then we have a vertical compression. Remember, a compression is when it's between 0 and 1 of 1/2. We are going to be going down 5 and then right 2. And I'm underlining these all in colors because I want to show you what goes with what. So it's going to start with y equals, and we learned from our last unit that if there is a compression or a reflection, that will go in the very right after the equal sign at the very beginning. So a compression of 1/2, and then we have our parenthesis with our x in it. These ones are kind of messed up. They're kind of flippity flop flopped. So right and left actually go inside the parentheses. So this right 2 is going to go in there. And remember, when you go right and left, you do the opposite of what it says. So I'm going to have a -2, and then I'm going to square that. And down 5 goes after the parentheses, and it does what it says. So -5. So that's my equation for that one. Notice the vertical compression came from this box, right 2 came from my last box, and down 5 came from my middle translation box. Next, we are going to have a square root. So we know its parent function looks like square root of x. So how are we going to mess with this one? Well, this one we're going to have a reflection over the x-axis. We're going to have up 2. Ooh, my paper is getting all crazy. And we're going to have left 4. So on this one, we have y equals. We're going to start with y equals. Okay, now reflection over the x-axis. Reflection over the x-axis. So what we need to know is when we have a square root of x, when we reflect over the x-axis, does it go in here or does it go outside? Well, the x-axis one goes on the outside. If it were y-axis, it would go on the inside. So reflect is going to go outside. Then square root. And then inside the square root is my left or right. We're going left. So opposite of what you would expect. Left is a negative direction, so opposite would be plus our 4. And then here we have up 2. This one is outside the radical, and it does what it says, so plus 2. Our next one is a cubic. Cubic is y equals x to the third, cubic. So we have a vertical compression. Well, that's a big compression. Vertical compression of 1/8. If your paper says 1/9, please change it to 1/8. It looks like we don't have up or down shift, but we do have a right 5. So I want you to try to write this equation. I'll start you off. Go ahead and pause the video and try to write this one. How many of you actually paused the video and tried to write that one? If you did, I'm very proud of you. If not, man, do what I ask you to do, y'all. So right 5, opposite, so we have a -5. We have our 1/8 out in front. Okay, so now would be another good time for you to pause the video and maybe try to write number 4 and 5 on your own, because on your assignment, you're going to have to write all of these on your own. So number 4, we have a cube root. So that's when the 3 goes in the index. We have a vertical stretch of 3, so that's going to make it taller and kind of narrower. And we have down 4 and right 1. down 4, right 1. So y equals, which of those things comes first? Hopefully you remember that it's the stretches or compressions and reflections that go first. And then we have our radical with the 3 in the index and our x. Remember, under the radical is any right or left. We have right 1. Right is a positive direction. Opposite of positive is negative. So -1. And then we have down 4. So outside of the radical, down 4. And then we have absolute value, which is the absolute value bars with an X in it. Ooh, this one's got a lot going on. This one has a reflection over the x-axis. It also has a vertical stretch of 4. So we're going to have to talk about which one of those goes first. And it goes up 7. So y equals, for this reflection, we need to have, like we talked about on number 2, the negative has to be out in front. We also have a stretch of 4 that needs to be out front. So do you think it makes sense to write 4 and then a negative sign, or should we write our negative sign first and then 4? Hopefully you think it makes sense to write our negative sign first and then the 4. This is one of those confusing ones, though, because sometimes when people see this -4, they think, oh, it's a compression because it's smaller, it's not bigger than 1. But it's actually two different things. The negative is a reflection and the 4 is a stretch. So when you have both a negative and a number in front of your parent function, the negative is its own, it's a reflection, and then the 4 is all by itself. So you still look at if the 4 is bigger than 1, and it is. So that's why this is a stretch. Then we also have up 7, which goes after my bars, and +7. Okay, last but not least to write, the reciprocal, 1 over x. No vertical stretch or compression for this one. Up 3 and left 6. Y equals 1 over x. Which one of these goes in the denominator with the x? Hopefully you're aware that it's the left 6. Left, we think negative, but we do the opposite. So plus, and up is outside, so that does what we expect it to do, +3. Okay, now we are going to flip over to our graphs and graph these. So I wrote out all of our functions just so we would have them and you wouldn't have to keep flipping back and forth. So you can write them down. Number 1, we're going to do y equals 1/2 x minus 2 squared minus 5. So the first thing that we need to determine is where the start point is. So when this is an x squared, our start point is actually a vertex. So where is our vertex for this one? Well, your vertex is opposite of what's on the inside. So inside our parentheses, we have a -2. So my vertex is going to be at +2, comma, and then after stays the same. So +2, -5. So we are going to go right 2 and down 5 to get to our vertex. Now for a parabola, our pattern for growing is over 1, up 1, over 2, up 4, and over 3, up 9. Hopefully you have that memorized for your daily quiz. The only thing we have taken care of the 2 and the -5, they get taken care of for your start point or your vertex in this case. We haven't taken care of the 1/2. The 1/2 always multiplies our ups. So our multiplying our ups by 1/2. So I am going to go right 1, 2, and 3, but only up 1/2 or 0.5, 2, and 4.5 or 4.5. So right 1, up 1, right from my starting point, right 2, up 2, from my starting point, right 3, up 1, 2, 3, 4.5. And then if I wanted to go a little extra, I could go right 4. Normally it would go up 16. 16 times 1/2 is 8. Okay, just to be a little more accurate, you do not have to put that one on if you do not want to. And then remember, a parabola has the mirror points, so anything that we have on the right, we have on the left. So the mirror points on the left. Then we draw in a nice smooth curve. This is going to be a little bit wider than our normal curve because of that compression. All right, now let's talk about domain and range. Well, the domain for this parabola, just as for every parabola, is all real numbers. That's weird looking. Can't come back from that. Scribble that out, sorry. The range is from bottom to top. So if I scroll up, here's the bottom of my parabola. The y value is what I want because range is always y's. The y value is -5. I can also tell that from my vertex. The y value is -5. Is my parabola above -5 or below? It's above, so it's greater than or equal to. Next one, we have a square root or the eyebrow function. So again, we need to figure out where your start point is. This one does not have a vertex because it doesn't have symmetry. It doesn't have two things that do the same thing. It only has one. So its start point is going to do the same thing though, opposite of the inside. So it says 4. We're going to do -4. Outside stays the same, so 2. Left 4 up 2 is my start point. Then normally my pattern for growing for a eyebrow is over 1, up 1, over 4, up 2, and over 9, up 3. However, with this negative, we know that we need to change the signs of all of our y values so they're actually going to go down. So we're going to go right 1, down 1, right 4, down 2, and right 9, down 3. Do we need to stretch them or compress them? So looking out front, is there anything to multiply them by? Nope, just the -1. So we will go right 1, down 1, back to your start point, right 2, 3, 4, down 2, back to your start point, right 9, down 3. And that looks like our little eyebrow. So we'll draw that in. Remember, it should look like, if you turn it, it should look like half a parabola. So domain and range on this one, this is one of the trickier ones. Okay, domain, remember, is always x. Range is always y. So if I'm looking at my domain, I'm going to use the x value of my start point, 4, and for the range, I'm going to use the y value of my start point. So if I look at domain, here is where my blue graph starts. Is it above -4, like greater than -4, or is it less than -4? Well, all of the numbers that it touches are numbers that are bigger than -4. So I'm going to say greater than or equal to -4. Now the y, we're used to it also saying greater than or equal to, but in this case, see how it goes down below? So 2 is where we're starting, and we're asking, is this graph above 2 or below 2? Well, since it's going down because of that reflection, it's going to be less than or equal to 2. Our next one is a cubic. We need to talk about its start point. So its start point is opposite of what is on the inside. So inside says -5. The opposite of that is +5. And then comma, whatever's after. Well, there's nothing after. So when there's nothing there, it's 0. So we are going to go to the right 5, up and down 0. There's my start point. Normal pattern for growing for this guy is over 1, up 1, over 2, up 2 cubed, which is 8. And same thing on the left. Left 1, oh, not same thing. Down 1, left 2, down 8. So reversed on the left. Is there anything messing with that? Well, it looks to me like this has definitely been messed with. So we are multiplying things by 1/8. So that's going to be 1/8. That's going to be super fun to graph. That's going to be 1/8, and 1. Okay, well that's not a whole lot to graph. So let's see. If I go over, let's go over 3, just to add some more points. 3 to the third gives me 27. I would be going up 27. What is 27 times 1/8? Or we could just do 27 divided by 8. There we go. That's something else we can graph. So 3.375. So left 3, down 3.375. Okay, just to give it a little more shape. Because to me, that, which is what I got from my original points, is not a lot to go on. So to just round it out a little bit more, I'm going to go right 3 and up 1, 2, 3.375. And left 1, 2, 3, down 1, 2, 3.375. That gives me a little more shape. So as you can see, this one has gotten pretty squished. That curve is a lot flatter than it normally is. It's usually pretty steep. Domain and range on this one, though, does it start at an arrow and end at an arrow? Yep. So the domain and range for every cubic ever, there's no way you can change it. It's all real numbers. And again, you don't have to do these. They're just, if you had a really big a really small compression like that, it would help just to make your graph more accurate. Okay, number 4, we have a cube root. So cube root, we have to, again, talk about the start point. So start point for this cube root is opposite of what is on the inside. So 1, and then comma, what is on the outside. I'm trying to make it so my paper stops wiggling. -4. So to the right 1 and down 4. Right 1 and down 4. Then for a cube root, we do the opposite of what we did for a cubic. So for a cubic, we went right 1, up 1. And for a cubic, we did 2, 8. So we switch them. 8, 2. And then left 1, down 1. Left 8, down 2. Do we have anything messing with that growing pattern? Yes. Anything that's out in front of our parent function messes with this growing pattern. So I'm going to multiply all of these by 3. So I'm actually going to go up 3 and 6 and down 3 and 6. So from my starting point, write 1, up 1, 2, 3, and then write 8, up 6, and then same thing down and left. Okay, and this, remember, is the sideways one. So it is going like that. So the last thing we have to do on this one is domain and range, and I'm kind of running out of room, so I'm going to do it over here on the side. Domain and range, just like for cubics, for cube roots, is always all real numbers, and nothing is going to change that. Last 2! Woohoo! Sorry if that was loud. Okay, for number 5, our starting point, we do opposite of what's inside. There's nothing there, so it's going to be 0. And then comma, what's after. After is 7. So our starting point is over 0, up 7. And this is an absolute value, so we know it's going to be a V. Its normal pattern for growing is over 1, up 1, over 2, up 2, and over 3 up 3. But we have a lot that's going on here. This negative, what does that do to these ups? Hopefully you know that the negative actually makes them go down. And then the 4, being a stretch, multiplies them. So we're going to go over 1 and down 4, over 2 and down 8, over 3 and down 12, if we can make that happen on our graph. So over 1 and down 1, 2, 3, 4 on both sides. Remember, it's symmetric, so right and left is the same. Back to your vertex, over 2 and down 8. And back to your vertex, over 3 and down 12. Did I miscount? Yeah, I sure did. Ignore that point. That doesn't exist. Okay. All right. Then our domain and range for this one. Domain, can I go left to right and put have it all real numbers? Yep, just like a parabola, the domain is always all real numbers. Now the range, we always do y. We look at our y value. So my y value of my start point is 7. So is this absolute value v happening above or below 7? Well, it's all below 7, so it's going to be less than or equal to. Last one. This is our one with force field lines. So our start point here is opposite of the inside. Now, inside in this one is weird because it's in the denominator. And then outside stays the same. So -6, +3. We draw our black hole, because remember our start point is really our black hole on this one. And we draw our force field lines right and left. Remember those are called asymptotes, which is a funny word to me. It means right now on this kind, they cannot touch or cross. And we'll talk about some other kinds where it can. Our pattern for growing for these ones are right 1, up 1, right 2, up 1/2, and right 1/2, up 2. Let's see if there's anything to mess with that. Nope, we don't have a stretch or compression. So right 1, up 1, right 2, up 1/2, right 2 up 1/2 and right 1/2 up 2. And then we do the same thing left and down. So left 1 down 1, left 2 down 1/2, and left 1/2 down 2. Drawing our nice smooth curve, remember getting closer to that asymptote but never touching or crossing that force field line. Okay, and domain and range on these ones is all real numbers except couldn't remember how to spell except there for a second, except where your black hole is. So x cannot equal the x value, which is -6, and y cannot equal the y value, which is 3. So domain will have the x of -6, first one, and range will have the y of 3, the second one. Okay, bring these notes to class and let us check them off, and then we'll work on